Hello, Longhorns. Okay, we're going to begin this test 3.1 review. I'm going to try to do this very quickly. If you need to rewind or go back to check what I've talked about, then go ahead and use the rewind. Okay, so for questions 1 and 2, we're going to use the same function. It's going to be negative 3x minus 6 over x minus 5. And what we're looking for are the vertical asymptote, the holes, the horizontal asymptote, and the domain. Okay, so the vertical asymptote is going to come from the denominator. What makes the denominator equal to 0? So we're going to set the denominator equal to 0 and solve for x. All right, so x minus 5 equals 0. And when I solve for x, I get x equals 5. This is also my vertical asymptote. Now I'm going to look to see if there's any holes. Now to find holes, I need to make sure that I factor completely the entire function. All right, so I factored this function completely. In the numerator, I factored out a negative 3, and I'm left with the negative 3 times x plus 2. And then in the denominator, I have x minus 5. Well, I don't have any values for x that make the numerator and the denominator equal 0 at the same time, so in this case, I don't have any holes. No holes. Okay, horizontal asymptote. In this case, I want to look at the degree of my numerator and denominator polynomials to see if they're the same or if they're different. In this case, our degrees are the same. So if our degrees are the same, then we're going to divide the coefficients. So negative 3 over 1 is negative 3. So my horizontal asymptote is going to be y equals negative 3. The domain for my graph also comes from the denominator. So the domain is going to be all real numbers except whatever x value in the denominator makes the function undefined. So I'm going to solve for x. So again, I'm going to look at my asymptote. Here my asymptote is x equals 5. So right here x equals 5. So this is the number I'm going to use in my domain. So that number here is going to be right here as well. So I'm going to go ahead and write it in. Okay, we're not including 5, so we put a parentheses. And so it just shows in the domain that domain can be all real numbers except 5. Okay, so question 2 says graph this function and its asymptotes. Well, we're always going to graph the asymptotes first. So our vertical asymptote was x equals 5. So over here where x equals 5, I'm going to draw a line. I'm going to go ahead and make it red so it shows up real pretty. Okay, this is my vertical asymptote. My horizontal asymptote was y equal negative 3. So right here where y equals negative 3, I'm going to put another asymptote line, which is going to be my horizontal asymptote. And then I'm going to graph my curve. So one good point to look at is where is the y-intercept? So if you can find the y-intercept, then you can find one of your points and you can get an idea of where your curve is supposed to go. So when I look back at my function and I solve for my y-intercept, I find that my y-intercept is 6 over 5. So it's not a perfect, pretty number, but I know it's a little bit bigger than 1, and it's positive. So I'm going to go ahead and put that right here. So right around in there, 6 over 5. And then I'm going to draw in my, sketch in my curve, which is probably going to go something like this. Okay, now the other curve ends up being like out here somewhere. So remember, there's always, it's a reflection. So reflecting across here, here's one of my curves. The other curve reflects over here. It's kind of off the graph, but that's where it would be. Okay, let's go on to number 3. Okay, let's move on to the next one. Okay, in question 3, we're going to find the horizontal asymptote. Again, we're going to look at the degree of each one of our polynomials, the one in the numerator and the denominator. If the degree is the same, then we just divide the coefficients. So our horizontal asymptote is going to be y equals 7 over 3. In question number 4, we're finding the y-intercept. In the y-intercept, all we have to do is make x 0 and solve for y. So just cover up all your x's, and that's going to be your y-intercept. 0, comma, negative 8/9. Okay, let's go on to question 5. Okay, in question 5, we have to state the domain of the following function in interval notation. So we need to factor the denominator to find the domain. So I'm going to find the two numbers that multiply to give me 2, that add to give me negative 1. Well, that's going to be 2 and 1. And I need it to be negative 1, so that means that my 2 is going to be negative, and my 1 is going to be positive. Now I set those equal to 0, and I solve for x. I get x equals 2, and x equals negative 1. That's going to tell me what my values are for my asymptotes. It's also going to tell me what my values are for my domain, because the domain is going to be all real numbers except where the asymptotes are at. So except, go ahead and write this in, negative 1 to 2, and then 2 to infinity. And that's it. And that's how we're going to write our domain in interval notation. All right, the next one, we're going to identify the wholes. So we need to factor this. Okay, first I'm going to factor the numerator, and then I'm going to factor the denominator. The numerator is the difference of squares. So it always factors like this. X plus the square root is 16. X minus the square root is 16. So that's my numerator. My denominator is going to factor what two numbers multiply to give me 8 that add to give me 2. Well, that's going to be 4 and 2. So again, I'm going to have a 4 and a 2. Which one's negative? Well, I need a negative 2, so the 4 is going to have to be the negative 1. Okay, so you'll notice right here that we have two factors that are x minus 4, one in the numerator and one in the denominator. Now, since that happens, that value of x makes a 0 in the numerator and denominator at the same time. When that happens, we have a whole. So we have a whole where x equals 4, because 4 minus 4 is 0. What I have left is x plus 4 in the numerator and x plus 2 in the denominator. So I know my x value for my whole is 4. But now what I need to do is find the y value. I'm going to plug in the 4 into the x, into the remaining equation right here. So this is what's left over after I cancel out my x minus 4s. This, I get x plus 4 over x plus 2. So now I'm going to substitute in this 4 into this x to get my y value. So that's 4 plus 4 over 4 plus 2. And that gives me 8 over 6, or 4 over 3. So the value for my whole is, the coordinate for my whole is 4, 4/3. All right, in the next problem, we're using the laws of exponents to simplify this expression. And so we're going to take our base of 7, and we have exponents of 11 and negative 2 in the numerator. And since we have a common base, we can add the exponents. So in the numerator, I'm going to end up with 7 to the 11 minus 2, which is 9. And then in a denominator, I still have 7 to the third power. Well, here the laws of exponents say that if I have a base, a common base, and I have exponents and I'm dividing, that I subtract the exponents. So 7 to the 9 minus 3 would be 7 to the 6. And I'm going to write it like that. I'm not going to multiply 7 together 6 times. I'm just going to leave it as 7 to the 6th power. All right, question number 8. Anything to the 0 power is what? It's 1. So I'm not going to do any of this stuff in the middle here. I don't really care what's in there. We've raised it to the 0 power, which means that's the number 1. In question 9, I'm using my laws of exponents again. I'm going to combine the left side. Since I have 8 to the x times 8 to the third, I'm just going to rewrite that as 8 to the x plus 3 equals 8 to the 14. Now that I've isolated my bases, I can go ahead and drop them. So I'm going to drop this base of 8, and what I'm left with is x plus 3 equals 14. And then I just solve for x, and I have x equals 11. And that's your answer. All right, so for problem 10, this is a rational equation that we are solving for x. And so the easiest way to do this is to find the greatest common multiple in the denominator. And our greatest common multiple for this denominator is this 8x. So what I'm going to do is I'm going to use that 8x to help me get rid of all this stuff that's in the denominators. Okay, so I'm going to take that 8x and I'm going to multiply all of my numerators by 8x, just like that. And then I'm going to go back in and I'm going to eliminate all of the, or reduce these fractions all down so that all I have left are some terms with an equal sign and no more fractions. So I'm getting rid of all these denominators. So in this first term, I can get rid of this 8. And the second term, I can get rid of the 8x. And in the last term, I can get rid of the x. And then I'm going to rewrite my equation. So here I have an x times 1, which is just an x. And then I have a plus sign. And then I have a 3 by itself. And the next one, I have an x times 8, an 8 times x plus 2. So in this case, we're going to multiply through 8 times x plus 8 times 2. So we're going to go ahead and write down our equation. And I have 8x plus 16. And then I'm just going to solve for x. Okay, so after I finished solving this out, I got x equals a negative 13 over 7. All right, last problem, yay. Okay, and this one I'm looking for the greatest common multiple. And it looks like it's going to be this 6x squared. And so I'm going to multiply all the numerators by 6x squared. And now I'm going to reduce. So the first one reduces out. So 6x squared over 6x squared is 1. And then here I'm going to reduce we're going to reduce this by 3x. So this is going to reduce down to 2x. And this 2x squared will reduce down to a 3. Okay. So now I'm going to add everything in the top. So 1 plus 2x times 2 equals 3 times 1 is 3. So we have 1 plus 4x equals 3. And then I'm going to finish solving for x. And I get 2 here. And an x equals 2 over 4, which is 1/2. And that's it, we're done. Good luck on your test. Come to tutorials if you need extra help, and let me know if you have any questions.